So that last video was actually our baseline flight for John and Jack Jet Company, our unmanned ornithopter. As you can see, it just took off and then it just dipped really quickly. So this was due to the fact that it was just like we weren't really good with how to do the mechanical rubber band system yet. So this will just go over summarizing our first two milestones. So this is PDR1 that I have shown. So this just talks about like what the project actually is. And then like the different operational leads, and then we have our customer requirements, system requirements, design requirement, and then we did a lot of analysis for these three. So like the first analysis is our SR1. This is a traceability block diagram and flow. This is the matrix for that. This is our video, and then our approach that we will use for the entire project. And then the second one is kind of just building off of that. So we have our approach that we have been using. And then this is mainly just like different design features and concepts, and then different measurements, different estimation processes that we're going to use later on, different design features like aerodynamic design, a propulsion system, different trade-off studies to define design requirements, fabrication, how to build the thing, different ground testing, and then our program and risk assessment to test safety factors and different stuff like that.
Okay, so as you can see, this is our new ornithopter design. We made a lot of improvements from the old designs. One of them was with the tail. As you can see, there's a little bit of overhang between where the tail starts, and where it is glued to the fuselage. We did this because in previous designs we didn't have this overhang, so adjusting the tail with our pliers and changing the angle was a lot more difficult. So we did that to make it easier to adjust and decrease the chances that we break it when we adjust it. And for the fuselage, you can't see, but between the second and the third design, we totally took it apart and re-glued it together and used more glue, and we're more conscious about gluing it together so we could add strength. With the stoppers, as you can see here, before we had tape for our stoppers, and before that we had rubber bands, but those both kept falling off, so we switched them to little bits of eraser to decrease the chances of them falling off during flight. And the last thing was our biggest change was our crank. You also can't see, but we used WD-40 to grease a lot of the moving parts. So like we put WD-40 here, and we put a lot here where the supporting rods connect to the wings. And we also put a lot in here where the pens rotate in between the tubes. And we believe that this helped us increase our flapping frequency and achieve more consistent flights. For the V diagram, for the user requirements and concepts of operation steps, from the user's perspective, the ornithopter needs to be an easy and simple to operate device that is powered by a rubber band and a flapping wing mechanism. For the system requirements and architecture step, the flapping flyer needs to fly for more than 5 seconds and also be able to do 10 flights in a row before break. Do 10 flights in a row without needing repair. And for the component design step, the flapping flyer will consist of the fuselage, the crank, the wings, and the tail. And all four of these things are made of a lightweight material. And the way that it works is the crank stores potential energy in a rubber band and then releases it into the wings in the form of kinetic energy so it can fly. And for the procure, fabricate, and assemble parts step, to assemble the ornithopter, we used all the parts that were provided. We did need to buy a few extra things for it to work from the store, however. And for the component integration and test step, after installing everything on the aircraft, we verified that everything worked in unison without breaking, and that everything worked well together. And for the system integration test, we tested the ornithopter a bunch of times, and we ensure that it can do at least 10 flights in a row without breaking. And also we ensure that it can maintain a flight time of at least 5 seconds for one of our designs. And for the system demonstration and validation, basically we would do this if we were going to sell it, but basically what we would do is we would manufacture a lot more ornithopters and then test each of those to make sure that they work and meet the requirements.
So if we decided to make different improvements or recommendations for the next time we did this, we would probably try to make the crank a little bit stronger, just because we had a lot of problems with this little piece snapping off right here. So you would try to make that a little better, maybe just a strong material. We would probably try to invest in like better stoppers. So like as you can see here, we just use like erasers. Maybe we could invest in like a wire stopper or something, just something more efficient. And then having like better connecting rods. Obviously, you can see here these broke after testing and stuff. So since this is the final rendition, we're not going to fix them just because we don't really need to. Um, I think we would just take more time, honestly, with like different project parts, maybe like the wings, just being more careful and stuff, and obviously just being more efficient with like how we glue and tape our parts with for our ornithopter, and then also maybe using thread just to keep everything more secure because we didn't get a chance to really use that and we weren't very familiar on how to use it. So those are just some improvements and recommendations for next time.